You're listening to AI Podcast. I'm Max, and today we're unpacking a NeurIPS paper called Deep Video Discovery.
Long videos and smart search. Give me the headline first. What's the big idea in plain English?
TLDR, the paper treats a long video like a searchable library, then lets an agentic AI plan its own search with a few simple tools so it can find and verify the exact moments that answer a question.
So not dumping an hour of footage into a giant model and hoping it pays attention.
Exactly. Instead, it builds a structured index of the video and equips a reasoning model with 3 moves. First, browse the big picture. Second, search for relevant clips. Third, inspect specific frames to double-check the details.
Nice. Who led the work?
One of the lead authors is Xiaoyi Zhang from Microsoft Research Asia, with Zhaoyang at the University of Science and Technology of China.
Got it. Before we dive into how it works, remind me why long-form video is such a headache.
2 reasons. Evidence is sparse and spread out, and compute is expensive. If the clue you need appears for 2 seconds at minute 40, a big context window still might miss it, and compressing the video risks deleting the clue.
It's like trying to solve a mystery by reading the entire city phone book every time. You either waste time or you skip the name you needed.
Perfect analogy. And earlier approaches tried 2 main things. 1, make models swallow more context or compress it. 2, handcraft a fixed search routine, like a rigid tree that always starts broad, then narrows.
And the limits there are pretty obvious. More context tends to get fuzzy, and a fixed recipe breaks when the question doesn't match the recipe.
Right. The authors propose something more flexible. They build a multi-granular database of each video, then let the agent decide which tool to use next based on what it has already found.
Walk me through that database. Multi-granular sounds fancy. What's actually inside?
Think of 3 shelves. The top shelf is global summaries of what the video is about and where high-level events happen. The middle shelf is clip-level captions and embeddings, which let the agent search semantically for a moment. The bottom shelf is frame indices, so the agent can zoom all the way in and look at raw pixels.
So map, street list, and magnifying glass.
Exactly. And the tools line up with those shelves. Global browse for context, clip search to retrieve candidates, frame inspect to confirm details.
What does the agent actually do during a question?
It runs a loop. It thinks out loud, chooses a tool, gets results, updates its plan, and repeats until it's confident. That's the agentic part. It's not following a fixed script. It's composing its own chain of actions.
Give me a concrete example. Say I ask, when does the chef add salt a second time in this cooking show?
The agent might browse globally to find the cooking steps, run a clip search for seasoning moments, then use frame inspect inside that time window to see the actual pinch of salt and confirm the second occurrence. It answers and cites the time span it checked.
That's a lot more disciplined than skimming the transcript and guessing.
Right. And the frame step matters because captions can be wrong or too vague. The agent can go back to pixels when it needs to verify.
How did they test this? Because toy examples can be misleading.
They evaluated on benchmarks built for our scale understanding. The main one is LV Bench, which uses long videos and challenging questions. They also looked at other long video sets like Long Video Bench, Video MME's Long Split, and Ego Schema.
And they compared against what? The usual suspects plus a few agent systems?
Exactly. They include strong vision language models that rely on long context or compression, and agent baselines that follow fixed search trees. The headline is that Deep Video Discovery reported state-of-the-art results on LV Bench and led on the other long video suites as well.
No wall of numbers, but directionally better across the board.
That's right. The interesting part is their ablation story. Each tool contributed. Removing clip search hurt the most, removing the frame inspection also hurt notably, and global browse still mattered for orienting the agent.
So the stack isn't decorative. All 3 layers pull their weight.
Exactly. They also noted that the choice of reasoning model matters. With a weaker planner, the agent tends to take shallow, unproductive steps. With a stronger planner, it composes deeper but purposeful chains.
That makes sense. If the conductor is better, the same orchestra plays a tighter performance.
Nice metaphor. Another practical detail is transcripts. When available, transcripts help organize the video and slightly improve results, but the system still leans on visual verification.
Okay, let's talk trade-offs. What should a cautious reader worry about?
First, reproducibility and cost. The best numbers use a proprietary reasoning model and multiple tool calls per question, which means real dollars and latency for hour-long videos. Second, content filters from providers can occasionally block queries, and that affects both baselines and this system.
So you can reproduce the pipeline with the released code, but matching the exact performance may depend on the model and the platform you use.
Exactly. Third, evaluation. Many long video benchmarks use multiple-choice questions, which are valuable but can't fully test open-ended reasoning or evidence citation. Adding more free-form tasks with verifiable evidence would be a good next step.
And there's the data construction angle. If your captions are off, your search might start in the wrong neighborhood. The frame inspection helps, but only where the agent looks.
Right. Garbage in, harder search out. Still, the design encourages verification, which is a step in the right direction.
I'm curious about deployment. Where would this shine first?
Sports analytics is a great fit. Ask when a team switched to zone defense the second time, and the agent can browse for quarters, search for defensive formations, and verify with frames. Another is lectures or hearings, where you might ask when a topic resurfaces after a long detour.
Or customer support reviewing a long screencast to find the exact moment a bug first appears.
Totally. Anywhere evidence is sparse over time.
You mentioned the agent plans its own chain. How do they keep it from wandering forever?
They cap the number of steps and bound the frame inspection to a small set, like a few dozen frames in a time window. So it's zooming in, but it's not scanning the entire movie frame by frame.
Efficient enough to be practical, but still grounded in pixels when accuracy matters.
Exactly. And that balance is the core contribution. They're not betting on infinite context. They're betting on smart search plus targeted verification.
What about future work? If you were picking next moves, where would you go?
3 ideas. First, teach the agent to learn better search habits from its own trajectories, so it needs fewer steps. Second, replace some of the heavy frame checks with lighter vision tools like trackers or OCR before escalating to a big model. Third, push for open-source reasoning models that can get close to the same planning quality to reduce vendor dependence.
And on the evaluation side, move beyond multiple choice and require answers to cite the exact frames used as evidence. That would really test faithfulness.
Absolutely, that would align the system's behavior with how we want it used in the wild.
All right, bring it home. What's the takeaway for listeners who want a mental model they can carry around?
Here it is. For long videos, don't try to remember everything. Organize the video into a searchable library. Give your model a small toolkit to browse, retrieve, and verify, and let it plan the path for each question. That combination beats brute force context and rigid workflows.
Right, thoughtful search over raw scale. Deep video discovery shows a clean blueprint that others can adapt, even as models and datasets evolve.
And that's our episode. Thanks for listening to AI Podcast.
If you enjoyed this, share it with a colleague who spends too much time scrubbing through videos. We'll catch you next time.